Hello, in this episode, we'll discuss about the causality in regressions and we'll introduce a method called synthetic control. So here's the motivation that if you have a regression coming out, for example, here a violent crime regressed on various factors, one of them being police force. Okay? And the results show that it's positively correlated. Police force has a 0.5 increase in one unit, increases 0.5 of the violent crime, and the standard error is small, so the ratio is way larger than 2. And does that mean that the larger police force cause more crime? Probably not, isn't it? The more likely scenario would be because there's violent crime, the city maintains a larger police force, something like that. But the limitation of the regression is that it does not tell which way the direction of the causality goes, because it can tell only correlation, cannot tell whether one caused the other. So what do? We saw one episode, the earlier episode, a difference in differences. Now we will see another method, which is called synthetic control. Okay. So here is a study by Professor Abadi and the co-authors who developed this technique called synthetic control. They look at a particular policy change, which was a Tobacco Tax and Health Protection Act, which was in 1988 adopted in California. It's called Proposition 99. What it did was that it imposed a tax on tobacco and also other similar tobacco products. It also banned cigarette vending machines in public areas, which can be accessed by young people, and also there's individual sale of single cigarettes. And the revenue generated from this tax is basically used for various anti-tobacco advertisements. So you can see that this was a strong policy to curb down the cigarette consumption for public health. All right. So how did it work out, the policy? Well, here's the nationwide non-California cigarette sales over the years. Okay, so overall, we are in the downward trending trend, okay? Living a healthier life, probably. And here is California, which is also following downward trend, okay? And here in 1988 was when the law was enacted, okay? Note that California was actually lower in cigarette sales than the national average already before the act. The gap seemed to have gotten wider. The question really is, how much of this gap is due to Proposition 99? Did it work? Did it not work? How much can we put the causal relationship between imposing the cause of Proposition 99 and the impact on lowering the tobacco sales, especially in California here? So how do we do this? Here's what Professor Abadi and Heimler and this authors did. The idea is that here is a national average from all the other states. In fact, they didn't use all the states. They used like 39 states, which didn't have a tobacco law at the time of 1988. And among those, California then will be adopting, so they see the change. Okay. Anyway, so here's the national, so all the other states. Okay. And what they think is that, okay, can we create a synthetic California based on the other states? What it's trying to say is that have a sales of Alabama, weighted with Alabama, and added, and weight of Wyoming, sales of Wyoming, and so forth, isn't it? So that's a weighted average. The question is, how do we choose the weight? But can we do it in a way that weighted average, we call it synthetic California, the sales of tobacco kind of matches the actual California before the law was enacted. So it is like a California, synthetic, hypothetical California constructed based on the other states. Okay, so like shifting this line here. Okay, all right. So match it, determine the weight such that it will match the California really well. Okay, all right. Okay, and then having those weights, okay, and the sales of other states will change also in their own ways, but we keep the same weights and then look for the synthetic California and see how the synthetic California have changed. And that we take it as a counterfactual of if that synthetic California had not passed the law, how would the tobacco sales would have looked like? And we don't know which way it goes. Okay. And compare it against the actual California after the California was passed. And this gap here, then we call it the causal impact of California passing Proposition 99. Pretty neat idea, isn't it? A lot of economists are fairly passionate about this. So it's the new popular toy in town. All right. So here's the actual result. So the synthetic California, and you can see that the synthetic control method does a really good job in matching the pre-intervention California actual sales and the synthetic. And then afterwards, when we fix the weight, and then let go, the California is here, and the synthetic California, hypothetically not passing the law, is here. And there is a substantial gap, which we can say that the Proposition 99 had an impact on curbing down cigarette consumption. Okay? So these are the people, Abadi, Diamond, and Hein Müller. They did an awesome work of coming up with this idea. Right? You can, in fact, just net out and plot the difference. Here's the net difference. And you can see that the Proposition 99 sales actually had a dramatic effect here. So this, you can actually try it in Python, and kindly a number of people provide the Python code. So here I'm just going to introduce, so it is not my invention, of course, but here for one of the website is, and I just slightly modified to fit it in Google Colab. But here is, for example, the website, Causal Inference for the Brave and True. So the code is here. In fact, it gives a fairly detailed kind description. So I highly encourage you to read this website here. But I'm just gonna take down the Python code part with minimal documentation. But please visit the website and look at it. It's really nicely, kindly written, very easy to understand. So what this does is that, so there is this website that gets you the data, and the data is smoking. Actually, the original data, let me just make, the original data is smoking underscore data, which has 1, 2, 3, 4, 5, 6, 7 columns. And the retail price is the price of the tobacco sales that we want to know. The cigarette sales is what we want to know. I actually created 2 more columns, which would be, well, here the state. I create a California variable, and let's see here. And so I create another file called smoking, which is the same, but I created the California variable, which is false if it's not California, and true if it's California. And the after treatment, if the year is after 88, so up until 88, it's false. And then true if it's 89, 90, and so forth. And each states are coded, number coded here, according to FIPS standard post office code. 3 would be California, okay? So 3 would be California. You can see it's true here, okay? So I'm using that smoking data here instead, okay? Which comes from the original data, of course. So having read in smoking, and I'm gonna just keep the log income, beer, and age. I'm gonna drop these and just keep the sales and California and the post variables. Okay. So here is to check the data. So how does the California data look like? We already saw in the Excel sheet, but here it's how it looks. And California and after treatment variables are my important variables, along with cigarette sales. Okay, there's a control variable, retail price, and how it looked before. So you can just plot it. It looks like here, like this. So let's prepare the data. So here's a little bit of trick that I guess you can just copy it, and it's of course given by the original author of this code. So here, so what does it do? The cigarette sales and retail price are the features. And we create a table. We have to create a table that basically looks at not after treatment. So meaning before California passes the law, keep only those information, and then have a state to year pivot table, meaning it's like a spreadsheet. Okay? But I'm going to transpose it, flip it, so that the rows are the states and each are number. 3 will be California, okay? And there's 39 states. And the year would be the rows of the cigarette sales. So it's kind of what we call pivot table. It's like a reference table. Okay? And it uses only the before California passes the law. Okay? So that's a little bit of a Python trick. And then the Y variable would be California, okay? And the other states will be X's, okay? You can check. The inverted table has 38 by 39, 38 years, 39 states. So if California had just 38 of these, then we're pulling this column, and then the rest will be then 38 years, 38 states. Okay. So how do we actually pick the weight? Pick the weight in a way that minimizes the pre-law change California cigarette sales, isn't it? So here's our Y, California, and here the other states, X, each weighted, isn't it? Each are weighted, the weights. How do we pick the weight? Telling you X, the sales of each state, dot product with the weight. So whatever weight we pick, okay? We can pick a certain combination of weights and multiply it with X and have a synthetic California. It may not be the best one, so we take the difference with Y and have to square it. So the mean square, that's the loss. If it's large, then the weights are poorly picked. If it's very small, close to 0, then the weights are excellently picked. Right? So that's our loss. And how do we get the W? So here's another function. Basically start to randomly picking the weight and then have an optimization function, which basically have the loss being minimized. We want to minimize this loss, the difference between California sales and the synthetic California, given a weight. There are some conditions. The sum of the weight has to sum up to 1. And also we want the weight to be bound between 0 and 1. Okay, so here's the loss function, here's the weight. So get the California weight, so get to WXY, now it's a matter of just calling it, the other states and California, and I can just print them, how it looks like. The weights sum to 1, as we said, and then here are the weights for the 38 states, and you can see that not all states are useful, only a couple of states here are useful, okay? And that's a very nice feature. You can clearly see which states mattered in mimicking pre-California, pre-law change California. And how do you get the synthetic? Well, I can ask the California, not California, pivot table of the year of the state cigarette sales, okay? And have the value dot with the CA California weight, have the dot value of it with the rest of the not California state cigarette sales. And that gets me the synthetic sales. Okay, these numbers are hard to see. So let's just have a nice plot. So it's the cigarette sales of the California and the CA stints, the synthetic California. And you can see that California is below, especially after the law change. You can just look at the net change, of course, right? And plot here the California minus California synthetic, and I can see the net difference here. So this was just the code. I'm just introducing it from this website. But this is how, and there are a number of other websites that does provide Python code for how to do synthetic control, this being one of them, a nice one of them. So here in this episode, we explained how synthetic control works and introduced a Python code and how it works. Thank you for watching this video.